The world was running out of white gold. The electric car dream was dying. But then, scientists looked inside a 300-year-old paint pigment and found the key to the most abundant battery on Earth. It's not lithium, it's salt. And that is how the seasoning on your fries just became the most valuable resource in the world. Introduction. The spark. Did you know that the secret to powering the entire planet has been sitting in your salt shaker all along? For 20 years, the world was locked in a lithium fever. We tore up deserts and drained oceans to find the white gold needed for our phones and cars. By early 2025, that fever didn't just break, it shattered. The mines were depleting, prices were catastrophic, and the electric revolution was about to stall forever. Global supply chains were at a breaking point, and the dream of a green future was slipping through our fingers. We were desperate. But what if I told you the solution wasn't a rare, guarded mineral buried in a few select corners of the earth, but a common seasoning that usually explodes when it touches water? Part 1. The Lithium Trap. To understand where we're going, we have to look at the trap we built for ourselves. Since the 1990s, lithium ion has been king. It's light, it's dense, and it's powerful. And for a while, it worked. But lithium is a diva of the periodic table. It's hard to find, environmentally devastating to refine, and, as many found out the hard way, it's prone to thermal runaway. Essentially, every smartphone and EV was carrying a tiny expensive bomb. By 2024, the lithium monopoly meant that if you didn't own the mines, you didn't own the future. Countries were fighting over dusty flats in South America, while the rest of the world watched their energy independence vanish. The desperate need wasn't just for a battery. It was for a way to break the chains of scarcity. We needed a battery that didn't cost the earth or a war to produce. Part 2. The forgotten element. Enter sodium. If lithium is a rare diamond, sodium is the sand on every beach. It's right below lithium on the periodic table, making it a chemical cousin. It's everywhere, in our oceans, our crust, and our food. It's dirt cheap, and it's incredibly safe. But there was a massive physical problem that stumped the world's greatest geniuses for over 40 years. You see, sodium ions are fat. They are significantly larger and heavier than lithium ions. In the microscopic world of battery chemistry, size is everything. Trying to force these bulky sodium ions into a standard battery's crystalline structure was like trying to fit a bowling ball into a toaster. Every time scientists tried to charge a sodium cell, the internal structure would expand, crack, and turn into useless dust within just a few cycles. For decades, sodium ion research was a graveyard for scientific careers. It was a joke, until an accidental genius looked at the problem through the lens of ancient art. Part 3. The secret in the paint. The why finally changed in a laboratory in 2024, and it didn't happen in a high-tech energy seminar. It happened because researchers started looking at Prussian blue, a synthetic pigment used by artists like Hokusai and Picasso for centuries. While testing materials that could survive the fat sodium ions, scientists realized that Prussian blue wasn't just a color. It was a fortress. Its molecular structure formed a perfect, wide-open scaffold with giant empty spaces. Therefore, the bulky sodium ions didn't have to force their way in. They could glide through these wide corridors without stressing the material. It was a bridge built from 18th century art to solve a 21st century energy crisis. Suddenly, the bowling ball didn't just fit the toaster. It had a 10-lane highway to move through. Part 4. The 2026 explosion. As we moved into early 2026, the theory became an industrial wildfire. This is where the "and that is how" payoff truly hits. Because sodium-ion batteries are chemically similar to lithium, companies realized they didn't need to build new factories. They just had to swap the ink in the printer. Almost overnight, gigafactories in China, Europe, and the US began switching lines. The results were shocking. These batteries don't catch fire when punctured. They can be shipped at 0 volts, making them perfectly safe for planes. And most importantly, they thrive in the cold. While lithium EVs were dying in Chicago winters, the sodium-ion cars were starting up at 20 degrees without breaking a sweat. And the cost? A staggering 40% cheaper than anything we've seen before. The desperate need for cheap, safe energy finally met its match. Part 5. A world reimagined. Imagine a world where energy is as common and as cheap as salt. We are currently witnessing the birth of the salt grid. We aren't just talking about cars anymore. We are talking about massive storage banks in the Sahara and the outback, soaking up the sun and storing it in giant tanks of brine. Nations that were once energy poor because they lacked lithium mines are suddenly becoming energy rich because they have coastlines. The monopoly of white gold has been broken by the blue revolution. From the budget EV in your driveway to the power grid of entire developing nations, the geopolitical map of the world is being redrawn in real time. Conclusion. The payoff. We spent half a century and trillions of dollars looking for the rarest, most temperamental materials in the universe to power our lives. We climbed mountains and searched the deep sea, only to realize the answer was sitting on our dinner table the whole time. It took a global crisis and the brink of an energy collapse to make us look down at what we already had. Nature gave us the solution. We just had to be desperate enough to see it. And that is how common table salt became the fuel that finally saved the future.